When we take a measurement of a number, we only know it to a certain precision. So we can state our knowledge of a measurement through the use of something called significant figures. And sometimes I abbreviate this as just sig figs, okay? So significant figures, tell us how well we know a measurement or a number to a certain precision. Now, here maybe you've noticed that I've sort of written out the digits in pi, but only to a certain level of significant figures. So this number here, 3, only has one significant figure. The number 3.1, that number has 2 significant figures. 3.14 has 3 significant figures, so on, 4, 5, 6, okay? So that means that if I have a number up here and I'm reporting it to 6 significant figures, that means that I actually know the precision of that number really, really well. I made a really precise measurement in order to get that number. Okay, now let's look at a couple of other examples of significant figures. So let's say that I have the number 3.1300, okay? Even though there's zeros here, the fact that I put those zeros here is significant, okay? So this number, even though it doesn't end with a non-zero digit, if I keep those zeros after the decimal place, those zeros must be significant. So this number here, 3.1300, this number has 1, 2, 3, 4, 5 significant figures. Now, if you took this measurement and you really only knew it to the precision of the second decimal place, then you better write that number down as 3.13 such that it has 2 significant figures. But if you're putting those 2 zeros out behind it, that means that you know the precision of that number all the way out to the 3rd and 4th decimal place. So let's think about numbers that are smaller than 1. Let's say I have this number 0.001. There's only one non-zero digit. Okay. All of these zeros in front of that non-zero digit here are not significant. And so this number only has one significant figure. Now if I had 0.0010, I'm reporting an extra digit here. This number has 2 significant figures. Okay. And then if I'm thinking about writing my numbers out in scientific notation, if I said 3.10 times 10 to the 2, this number has 3 significant figures. Okay, because that 0 out here after the decimal place is significant. And if I took that measurement and actually I only knew it to the accuracy of that first decimal place here, I better write that number as 3.1 times 10 to the 2, which has 2 significant figures. Okay, now something else to keep in mind is that if you see a number that looks like this, 3 times 10 to the 2, this number only has 1 significant figure. Okay, if you want it to have, let's say you took a measurement and you found it to be exactly 3, and you knew that precision out to 2 decimal places, you have to write it like this. 3.00 times 10 to the 2, and that gives you 3 significant figures for that number. Okay, well, one more thing. Let's say I have this number 30. Okay, 30, as it's written right here, only has 1 significant figure. This number, the 3 out in front here. Okay. But if I took a measurement and I found it to be exactly 30 units and I know it to the precision of this decimal place right here, then I would say 330 point, put a little decimal place after the 0 here. And so if you see a number that has a decimal after a 0 like this, then that means that both of those digits are significant. Okay, and so then this has 2 significant figures. So whenever you multiply or divide several numbers together, or when you take their roots, if you have to take the square root or the cube root or the fourth root, the number of significant figures in your answer should match the number of significant figures as your least precise known number used in the calculation. So, for example, if I took the number 3.73 and I multiplied it by the number 5.7, my answer should only have two significant figures. This first number here has three significant figures. My second number has two significant figures. And so whenever we're multiplying, dividing, or we're taking the root of a number, our answer can only be known with the precision of our other numbers that we're using that has the least precision. So that means that my answer can only have two significant figures. So whatever this answer turns out to be, I have to round it so that it only has two significant figures. So then I would round it to just 21. Okay, now, we go through all this to talk about it. But the thing to keep in mind is that whenever you're entering answers into Canvas, Canvas does not care about significant figures. And the way that I set the tolerance on the Canvas problems is that you have to report the answer to within plus or minus 2% of the actual value that you get whenever you keep all these numbers together and you don't round and you don't think about significant figures. So whenever you're actually inputting a number into Canvas, you need to keep all those digits as far as you can and use that to get your final answer, which you put into Canvas, to plus or minus 2%. That doesn't mean that you have to type out all the long string of numbers in the answer you're putting into the Canvas entry spot, but what it does mean is that the answer that you put in there has to be within plus or minus 2% of that actual number. So you can eventually round, which may be a good rule of thumb is to keep at least 3 or 4 significant figures in the answer that you stick into Canvas just in case, just to cover yourself so that it doesn't get counted as wrong, okay? Now, whenever we add or subtract several numbers, the number of decimal places should match the smallest number of decimal places of any of the numbers used in your calculation. Okay, so for example, if we have 18.54 and we're adding it to 106.6, okay, and if we do our addition down, so here we've got 4, we've got 6, 7, 8, 9, 10, 11. Doing it the old school way, 8, 9, 10, 11, 12, 13, 14, 15, 2, 1. Okay, so my formal answer is 125.14. But if I'm worrying about the significant figures here, I only know the 106.6. I only know that decimal place here out to 1 digit. For the 18, I know the answer out to 2 decimal places, but my answer can only be as precise as this answer right here, which I only know out to 1 decimal place. So then if I'm worrying about significant figures, my final answer has to be 125.1 instead of the 125.14. Keep as many of those digits as you can while you're working through the problem, and then you can round your final answer to the proper number of significant figures in the end. If I were asking you to perform a calculation and be sure that you think about the correct number of significant figures. And this really goes for any assignment, any homework problem that you're doing. Before we move on, let's do one final exercise. And we want to rank in order from the most to the least the number of significant figures in these following numbers here. So I've got 8,200, I've got 0.0052, I've got 0.430, and then I've got 4.321 times 10 to the minus 10. I'm going to call this first number A, B, C, and then D. Okay, So if we rank those in order from most to least number of significant figures, let's think about that. Well, this first number out here, 8,200, that only has 2 significant figures. 0.0052, this one also has 2 significant figures. 0.430, that 0 out here is significant, so this number has 3 significant figures. And this number, even though it's really small, times 10 to the minus 10, out here in the coefficient has 4 significant figures. So if we're ranking them in order from most to least significant figures, we're going to say that D is greater than C, which is greater than A, which is equal to B.